Alright, so let's look at the idea of homologous series, and we are moving on to from organic compounds that we did in the last class, in the last lecture. Now we are moving into the homologous series. So what does the word homo mean? So homo nonetheless here means same, and the word logos here means a series or a sequence or a pattern, something like that. Anything. Okay. So when you're talking about homologous series, there are a few things that we need to understand before we dive into what is basically homologous series. So let's dive into some concepts of the organic chemistry, and I'll tell you the names of a few compounds that we are going to be studying throughout the chapter. So we have alkanes, we have alkenes, we have alcohols, we also have carboxylic acids, and we are going to be doing esters. So these are 5 different compound families that we are going to be studying throughout the lecture. Now here, if I talk about alkanes, if I talk about alkanes, so alkane, this is just a brief introduction into all of these things. And the reason why it is important is that because to understand homologous series, you guys need to know what is the concept, main basic concept of the organic chemistry. So let's talk about alkanes. So for alkanes, we call these saturated hydrocarbons. Okay. And what are hydrocarbons? So whenever you see the word hydrocarbon, hydro stands for hydrogen, and carbon, of course, you know that's for carbon. So hydrocarbon is all the compounds that are made up of hydrogen and carbon. So what are alkenes? Alkenes are saturated hydrocarbons. And what are hydrocarbons? Hydrocarbons are the compounds made up of hydrogen and carbon. So let's take an example. Let's draw a structure of what an alkenes look like. So an alkene is going to look something like this. Okay, something like this. So what you need to understand here, if I tell you the basic definition of the homologous series, it says that the homologous series consists of a family of compounds with the same general formula, and we'll be discussing in detail what the general formula is, and similar chemical properties that we'll do later as well, because they have the same functional group. Now here we can understand what a functional group is. So let's dive in to understand what a functional group is. So a functional group is something that decides how this alkene or an alkene molecule or an alcohol or any other molecule or any molecule, how it is going to react with any other molecule. So here the functional group is the carbon carbon single bond, or you can just say the single bond here like this is the functional group. Why? Because when we're talking about alkenes, it is not necessary, because if you see that this is a two carbon molecule, this is not necessary. Alkene can also be a one carbon molecule. This is methane, CH4. Okay, so this single bond here is the functional group, and this single bond is going to decide how these alkenes are going to react with other molecules, which is what the functional group. And this is also the chemical properties, because when we talk about what chemical properties are, what we say is how these elements react with other molecules is something that comes under the heading of chemical properties. We're going to be looking at that in a while. Okay, so this is for alkenes. Now, if I talk about some more alkenes, this was CH4, and this here was C2H6, right? If I talk about two more alkenes, let's say I talk about a 3-carbon alkene, and I draw the structure, and we will get into the detail of all of how to make these structure. How do we know how many bonds? By the way, the bonds, you remember I told you in the first lecture that carbon can make 4 bonds and hydrogen can make only a single bond. So here if you see, if you take this carbon into account, it has make one bond here, one bond here, one bond here, and a single bond here. So basically, this is one bond for this carbon, and this is one bond for this carbon. Okay, so this is how it works. So if I just erase this, or maybe we can continue like this as well. So this is one bond for this carbon, one bond for this carbon, one bond for this carbon, and one bond for this carbon. And you'll have an H here as well. So carbon is forming, every single molecule of carbon is going to form, an atom of carbon is going to form four bonds. And hydrogen on the other hand, you can see it has just formed a single bond. Okay, just a single bond. So now this is now a three carbon. This is now a three carbon alkene. So if I write this, this is C3 and 1, 2, 3, 4, 5, 6, 7, 8, C3H8. Now if I draw another alkene molecule like this and consider these all the hydrogens, okay. So this now becomes C4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this becomes C4H10. So if you notice here, from the top, you had a CH4. Then when you added one carbon, you get a C2H6. Then you added one more carbon, you get a C3H8. And then when you add one more carbon, you get a C4H10. Now look at the pattern here. We were talking about the series thing in the homologous series. This is the pattern they were talking about. So whenever you need to remember in the homologous series, when you add a carbon molecule, you are going to be adding an H2 two hydrogen molecules as well. So you can remember it this way. Whenever you increase the number of carbon molecules, your total overall number of elements, or you can say number of molecules that you add, is a CH2. Because if you notice here, you had one carbon here and four hydrogens. When you go down the series, now here you added one carbon and you added two hydrogens. Okay, you did the same here as well. When you go down the series again, when you make a three carbon molecule, here you added one more carbon and then you added two more hydrogens, and you did the same here. So you need to remember that overall in the homologous series, whether we talk about alkenes, whether we talk about alkenes, alcohols, carboxylic acid, and anything, you need to remember that it is going to differ. The next molecule in the series is going to differ by a CH2 molecule. Okay, by a CH2 molecule. And this was for alkenes. Now, what you need to realize is that homologous series is different for every for every series. So for example, if I'm talking about alkenes, now alkenes is going to have its own homologous series. Alkene, on the other hand, is going to have its own homologous series. Carboxylic acid, on the other hand, is going to have its own homologous series. So all of these series have their own individual series. So there is one homologous series, or you can say there are four homologous series or five homologous series, because there are five things that we are studying: alkane, alkane, and the other three. So there are five different homologous series. So what we can generalize here is that there are five different homologous series, but what you also need to know is that this is part of the one main structure. And what does that mean is that in each homologous series, the general characteristics is going to remain the same. So for example, if I write here the general characteristics, you will understand what I'm talking about. Okay, so what are the general characteristics? The first thing that you need to understand is that when we talk about one particular homologous series, let's say we're talking about alkenes. So alkenes will have, all alkene molecules will have the same functional group. Okay, what is that? That is a C with a single bond, or you can just say the single bond. Now we're going to talk about alkenes. So alkenes, we have not done that right now, but I'll show you an example. So when you talk about alkenes, alkene has a double bond like this. So you can say that this is the functional group that is going to run throughout the series of alkenes. So one thing, what is that? They're going to have the same functional group. Now when we move to the second thing, that is they all have similar chemical properties. What does this mean? Now this means here, this does not mean that all of the elements in the homologous series, let's say alkanes, alkenes, alcohols, carboxylic acid, and esters, all of them will have the similar chemical properties. No, this is for you to understand that this here we are talking about individual series. So for examples, the series of alkanes is going to have similar chemical properties. The series of alkenes are going to have a similar chemical properties. The series of carboxylic acids are going to have a similar chemical properties throughout their series. So this is what you need to understand. There is an individual series going on here, and there is one whole general characteristics of a series. Okay, now this is the one more thing. The other thing here is that what we talked about before, that each member in the series is going to differ by an CH2 unit by the next. What does this mean? This means that the next molecule in the series of alkenes or alkanes or whatever will have an additional CH2 unit from the previous one. Okay, and we'll take one more example to clearly understand all of these 4 points. The last point is that there's going to be there will be a gradual change in their physical properties as they go down the series. As they go down the series. Now we'll take the example of alkenes to understand all of these 4 points a lot better. Okay, so let's talk about alkenes. Okay, I think it would be better to change the color for now. Okay, let's talk about alkenes. Now, alkenes, if I tell you the functional group of alkenes, this here right here is a functional group of alkene. This double bond is the representation, is the identification, is the recognition, whatever you want to call it, is the identification of alkenes. So let me draw a molecule. So let's say I draw this molecule. Okay. Now you'll also see the concept of the 4 bonds being applied, because if I compare this with an alkene molecule, so let's say I also draw an alkene molecule here, which is something like this. So what you noticed here is that here they have a single bond, right? If you see this place, there is a single bond. If you see here, there is a double bond. Now, when there is a double bond, you need to know how you're going to count this particular set of molecules. So let's talk about that. Now, if you talk about this particular carbon here, this particular carbon is bonded to one hydrogen here, these 2 bonds, and one bond here, and one bond here. So this makes a total of 4 bonds. Okay. And we talk about here, now this particular carbon is bonded to this hydrogen and this hydrogen and this bond here. So this is how 2 combined carbons have formed 8 bonds. Okay. While here, if we see that these are all the single bonds, so you say one bond here, one bond here, one bond here, and this one bond here. These are 4 bonds. And for this carbon, we have one bond here, one bond here, and one bond here, and one single bond here. So these 2 carbons have also formed a combination of 8 bonds, 8 single bonds. But here, there is one double bond, and the rest are the single bonds. Here you have all single bonds. And this is the main difference between alkenes and alkenes, because Alkanes, we call them unsaturated hydrocarbons, and alkenes, on the other hand, we call them. Sorry, I guess I said it in different. I said it the opposite way. I think we call alkenes as the saturated hydrocarbons, and we call alkenes as the unsaturated hydrocarbons. So yeah, that was a mistake. All right, so now we're talking about the fourth thing. Let me draw this here again once more. So here you have an alkene molecules. Now we'll see all the 4 points that we mentioned above. Okay, so let's talk about the first point. The first point of the general formula or the general characteristic says they have the same functional group. Now this is only just a single member of the alkene series. Okay, so if I also draw, let's say I draw two more molecules of the alkene series, this is how it is going to look like. And you can count the bonds yourself. You should be able to do that. So this is 1, 2, 3, and this is 1, 2, 3. This is 4. This is 1, 2, 3, and this is 4. This is 1, 2, 3, 1, 2, 3, and this should be the fourth one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So now you can see that I have drawn three different molecules of the alkane series. Now, the first thing to notice, they all have the same functional group. I think it's pretty easy to see that. Here you can see a double bond, here you can see a double bond, here you can see a double bond. So yes, they all have same functional group. And what does the functional group tells you? It tells you how this alkene molecule is going to react with other molecules. Okay, so this is the first point. Now the second point here is that they have similar chemical properties. Now of course we're going to be looking at in detail when we go to the reactions, addition and substitution reactions. But for now, that means that all of these alkene molecules, and even with the 4 carbons and the 5 carbon molecules of alkene, the chemical properties are going to be similar. That means with other molecules, they will more or less have the same sort of reactions. Okay, they all behave the same way. So yes, chemical properties. That's the second point. The third point, and that point is that each member is going to differ by a CH2 unit. Okay, now that is something that we have to see. So if you see here, if I count here, this is C2 and H4, right? And if I count here, this is 1, 2, 3, this is C3, and this is 1, 2, 3, 4, 5, and 6. So this is C3, H6. And if I count here, this is 1, 2, 3. Okay, I have drawn two C3s. Okay, let me just correct that. Let me just add one more carbon molecule here so that it makes a 4 carbon chain. Okay. Alright, so now this is 4 carbon. This is 1, 2, and 2, 3, 4. Okay, I'll have to make this in a proper fashion. Just a second. Okay, so this is 1, this is 2, and this is 3. And let me just remove these. So these 3 carbons here. And then we have 1 and 2. Then we have 1 here and 2 here. Okay, this is perfect. Now, can we count the carbons? Yes. C4 is a 4 carbon. That's 1, 2, 3, 4, 5, 6, 7, and 8. So if I look at the differentiation here, the first molecule had C2H4, the second molecule had C3H6, and the third molecule had C4H8. So now, if you see, all of these molecules are differing by a CH2 molecule. How? Because when you add a carbon molecule, when one carbon atom is getting added, 2 hydrogen atoms are getting added as well. So this is a ratio of +1 and +2. Okay, and this is going to be common in the general series, in the homologous series of alkenes, alcohols, esters, carboxylic acids, alkenes, everything. So these are the 4 points that you guys need to keep in mind about the homologous series and alkane and alkenes. This is just a brief introduction. Now in the further part, we'll go into naming these organic compounds and formally starting the alkenes chapter as well. Okay, goodbye.